Hi, everybody. Welcome to a brand new episode of the Clear Descent podcast. We have a special recording here with Cisco, and we're going to talk a lot about Wi-Fi 6E, a lot of good things coming out. And first off, just want to welcome Francois. Thank you, our co-host, for being here today. How are you, Francois?
Very good. Thank you, Roel. How are you?
I'm great. Happy to be here. And we also have our guest, Jim Florwick of Cisco. How are you doing?
I'm doing well today, and thanks for having me on today.
Yeah, we're glad you're here because we're gonna hear a lot about what's coming out this year with
There's a
Wi-Fi
lot.
6E. Quite a lot to consider, quite a lot to plan, a lot of planning that's going to need to take place. But we're happy to discuss about the new 9136. We're going to talk about AP power because that's different for Wi-Fi 6E.
Yeah.
And we'll touch upon AFC just a little bit.
Okay.
That's still in development, and also would really like to hear about this AI RRM.
Oh, I'm spending a lot of time there, so good.
Awesome. Why don't you let everyone know who you are, Jim, just in case anyone in the audience doesn't, the listeners don't know who you are.
Well, I am Jim Florwick. I'm a technical marketing engineer with Cisco. I've been with Cisco since 2007 when they purchased Cognio. So it's actually the first job that I wasn't looking for a job when I got it I've ever had. So I've been here and primarily on nothing but wireless, focusing primarily on the RF edge, which is kind of a specialty with all the layers above it. But layer 0 and 1 is my domain these days. It's a
Awesome.
good
And
time for it too, because that
it
is
is.
expanding rapidly.
Yeah, I think this is a lot of the biggest changes we've seen in Wi-Fi in quite a while. Probably, I mean, when I started doing Wi-Fi, it was the end days. So being able to see new frequency come out and be utilized is a big deal. And I think there's not many people, not a lot of us who have even realized how big it is, and hopefully we'll get to see it soon.
It's huge. and it's well, and it's different by virtue of the fact that it is different than any other spectrum we've had. So any spectrum grants that we've gotten, and you know, I don't want to give away my age, but I go back to before we had the word Wi-Fi, and from that point on with 802.11 technologies, um, it's been a lot of the same. Wi-Fi 6 was a big departure because we changed the PHY signaling, but this edition of spectrum and how we're going to use this spectrum is completely unlike anything that we've done in Wi-Fi before, and it really shows what we've learned through the years in Wi-Fi. So I'm real excited for it.
Cool. So why don't we dive into the new AP that,
How you get there?
yeah.
Okay.
What does it take?
What does it take? Well, it definitely takes new hardware. I've had a lot of that question. Can we do this with a software upgrade? And it's I can't make that radio radiate someplace it wasn't ever
That would be
designed to.
magic.
Yeah, it would be magic. Although I, I hear people talking about this now, so we'll see how much magic it takes. But it may be possible in the future. This does require a new radio, and our first entry, of course, is the Catalyst 9136 AXI radio. Um, it it's got a lot of radios in it and a lot of modes and a lot of space that I think it applies to. We at Cisco were the first and only in the first round anyway to release what I consider to be a truly enterprise class AP. And do you know? Well, let's go through the hardware on it real quick. What we offered was 2.4 gigahertz and a 4x4, and then I've got, much like the C9130, I've got an 8x8 mode in my 5 gigahertz, or I've got dual 4x4 modes, which I remember when we were releasing another 8x8 mode AP, everybody said, well, the only thing it's good for is MU MIMO. And I think at that point in time, a lot of people still didn't believe MU MIMO could be effective or work. And I can tell you, you want more spatial streams and more MU MIMO. It works real well now. So that and then the 6 gigahertz radio also at 4x4. And the thinking behind that was that we've got a lot of dual 5 gigahertz in place out there today. And for somebody to make that transition with the same sort of enterprise power that they've got out there today, they need 6 gigahertz, but they also, more importantly, in the short term, while, you know, the legacy clients are going to be around for a long time, also need to support probably more 5 gigahertz traffic than they do 6 gigahertz. So it made sense to us to be kind of at the top with an enterprise class release before entering the market at smaller AP levels.
So you could have, just to recap, you could have an AP, or you could configure the AP in a mode where you have a dual 5 gig and a 6 gig radio at the same time?
Yes.
Okay. And then the alternative would be 1 on 2.4, 1 on 5, 1 on 6?
Yes.
Okay. Interesting. Okay.
Yes.
Yeah.
So you can run an 8x8 or you can run dual 5, but you can run all the interfaces at the same time. That does take more power.
Yeah.
Okay. Yeah. And we'll go back to that discussion, right?
Yeah, we will. I know.
Now,
So
well,
go ahead, Roel.
I was going to ask, like, is it really challenging to place that many radios in an access point?
You betcha. Yeah, all the things that affect radio, you've got to think, and we're getting pretty good at it. They're shoving a lot more radios into the APs. A lot of it, you know, believe it or not, just on the funny side of it, our radios forever have been, you know, related to as you know, 802.11b or 802.11a, so many places in software. So a lot of it has just been getting down to eradicating the idea of a slot. You know, slot 0 for years was always 2.4, right? So there's a lot of areas in software that had to transition to accommodate these flexible radios and the multi radios. And the good news is, coming into 6 gigahertz, most of that heavy lifting's already been done. So yeah, there's a tremendous amount of flexibility built into it. The other challenge, of course, is getting all these radios in the same room together without them interfering. But that's just, and the chipsets really just keep getting better. It's amazing what we can do in silicon now.
Yeah, because I know there's a lot of clients that I run into that want a smaller access point, but then they want more out of it, right? So I can just see them asking, like, yeah, I do still want a super small form factor, but I still want 2.45 and 6 gigahertz just for, you know, future proofing. And so I always wonder, like, is it physically possible to get an AP that small but still fit all those radios in? Because I would assume that if they get too close, they would interfere with each other, right? Or do you have like these special isolators?
Well, yeah, there's a couple of ways. First, you know, with dual 5 gigahertz, we use polarity, frequency. You know, there's several ways to isolate that, or provide, you know, more isolation from itself. So Cisco's been doing that for a while with dual 5 gigahertz. The 6 gigahertz, ironically, is in a completely different band, right? So it doesn't interfere with the existing infrastructure. So from a 6 gigahertz standpoint, it was real estate. Now, from a shrinking standpoint, shrinking it down, you can get the radios in there. Usually what suffers is the antenna real estate, right? So you don't have as much room to spread out the antennas. And that's going to lead to more or less gain performance on the antenna side. So, you know, you see it now with like the 9105s, right? You can get a 9105 in a very small form factor, but that radio is not, it's not an overly robust AP. It's more than adequate AP for a teleworker solution, but it's not what you want to put up in a hall and say, hey, you can have up to, you know, 400 students on this, right? Would be a bad idea.
I wanted to, Jim, go back to the multi-user MIMO discussion, because I've never really seen it effective in the field. But if you're telling us that now it works, that now I'm interested. You know, what does it make it work now? Is it Wi-Fi 6? Is it better chipsets? You know, what's the advantage of getting all of these spacious streams? How would you sell it to someone technically? Yeah.
So a lot was made about MU MIMO, and that hurt us, about MU MIMO in 802.11 AC, which it certainly was possible. But with MU MIMO, it's opportunistic, right? Wi-Fi 6 parallelism is deterministic MU-MIMO is opportunistic because it's spatial, right? So what it relies on is the proximity of the clients as they're spread around the cell. And then what I do with the antenna phase is I tune higher gain to the group, to the MU-MIMO group I want to address, while simultaneously detuning and isolating the other groups. So normally that means, much like my mic with the figure 8 pattern, right? And how that rotates around to the different groups. What killed that was that means I need immediate sounding information from that channel. As a client's moving, that's changing continuously because they're in a different space. So I need really rapid response, or what they call sounding information on that channel, to be able to adjust that phase and keep that MU-MIMO group together. What that did in 802.11ac, being a serial protocol with OFDM, was meant that I had to send another packet and hope that every time I sent that packet, I was going to be getting more data down to an MU-MIMO client. And frankly, several of the client manufacturers didn't believe that that was going to be efficient. It turns out that it wasn't as efficient as people would hope, because you're sending another packet on the air that also requires access to the channel. What changed is Wi-Fi 6, okay? Wi-Fi 6 comes in, I can do things parallel. So I can send you a packet while I'm sending out a channel sounding, if you're not taking all of my slots on that packet, right? So now I have the ability to do that in parallel. It takes away the penalty from doing that. It's always been working, right? But also now the client devices are working with it. So before I saw OFDMA gains, and this was, we realized it in full packet testing. So with your full buffer testing, you're not going to see any OFDMA gains because it's all full packet. The MU-MIMO gains, you're not going to see any OFDMA gains when you're sending test traffic like full packet, right? Because the OFDMA gains come in by being parallel, right? And we know 80% of the packet is, or 80% of the traffic you got is just the chatty stuff that goes in between, right? It's all small packets. So there's plenty of opportunity to do this. We realized it in testing when we were seeing twice the PHY rate we expected to find with full packet testing, and realized, man, these things are really doing downlink. And then we started to test uplink, and we've got some code for uplink with the AX210 chipsets that works just fine too. So there's a lot going on in a Wi-Fi 6 AP now. And I tell people all the time, in fact, if you take a look at the C9120, because it's for spatial stream, it supports a maximum of 2 MU-MIMO groups. And if you look at the number of clients on a 9120, if you keep that to, 2 clients, 3 clients, you're going to see almost identical numbers for the 9120 as you will on the 9130. When you go to 15 client testing, or some non-even number where the 3 multi-user MIMO groups that the 9130 supports today is invoked, you will see it walk away in the capacity of that AP. It just really starts to stomp on the 9120, even with dual 5 gigahertz up, because it has those additional MU-MIMO modes. So my favorite way to deploy that today is 8x8. I'm glad that we held on to that in the 9136, because it makes a difference in the right environments. And if you think about it, most of the carpet office space, it's pretty much a circle around the AP. And for a lot of time, people aren't moving. So I think it brings a tremendous advantage now.
So you're still doing the sounding process, but you're doing it in parallel in like an OFDMA channel. Is that one I understood? Okay. Yeah. Awesome.
Sending it in one of the RUs instead of sending it individually and having to. And what killed us, of course, was getting channel access, right? At a time you're trying to economize and save, airtime, you're going and asking for more airtime so that you can save airtime. And, hopefully that goes well and you end up with a savings and not a cost, right?
Yeah, I know in my Wireshark, I have a filter in bright yellow for those sounding frames. So when I do packet captures, I know if a multi-user MIMO is enabled right away. It's like, right, it's shining at me.
Yeah, key is it's only Wi-Fi 6, clients. But I'll tell you something that surprised me there as we started to come alive back into the world too, was I started to hear back from, for a while there. I mean, while the world was closed, how do you know how much penetration Wi-Fi 6 has in the market? Because, you know,
Mhm.
we always look at shows, universities when they're going back and everybody shut down. And as they started to check in, 50% was not a odd number to hear when they were looking at what was loaded up on their system. So while we were all home, we bought the heck out of Wi-Fi 6 clients, and everybody brought them back to work. And
Mhm.
I've surprised some people with that, but on average, 50 to 60% penetration now. So it's a big deal.
Would you say like that would be the biggest challenge of this 9136 AP, like building that in, or are there other challenges that might have been, you know, more pressing to look at?
Wi-Fi 6, E, 6 gigahertz, and the rules. So that's the biggest challenge I would think right now. And not that it's challenging. Um, it always comes down to interpreting the regulatory, right? And sometimes things that seem very clear while they're negotiating it or talking about it in a regulatory don't wind up as easy to translate in the real world. And things that seem good, you know, we talked about some of the things that come with 6E, multi-BSSID, right? Being able to transmit and making that more efficient. And one of the first things that came out of that, you know, was whether we were going to do Phil's mode, whether we were going to do, you know, the automatic probe response, or broadcasting preemptively the probe responses. So a lot of that's been the challenge, a lot of talking and getting everybody on the same page. And it's been so fluid. One of the things that happens around here is we've got a lot of engineering resources, right? So a lot of decisions in the very early stages get made in one group, and the other group is coming from yesterday's version of that because it was moving so fast, right? So it's been a fun project to implement, and getting the first radios, you know, was exciting as it always is, right? But
Mhm.
it was also all new. And the next immediate problem I had was I literally didn't have any 6E clients, and of course, by then they were not exactly easy to get. So I had a couple of M2 chips here, and we cobbled some stuff together.
Yeah, so maybe that was the other part of the challenge is got the AP, but you don't have the clients to
Yeah,
to
well, and
fully test, right?
that's something that's been extended into the field too, because the client penetration when these first started shipping or when it was first out there was fairly low. There's a lot of clients out there now. There's a lot of it entering the stream now. So this is really
Mhm.
really the time to start looking at this. And I think um, what we mentioned at the top of this broadcast, this is a completely new technology, right? From a
Mhm.
Wi-Fi
Yeah.
standpoint, we're trying it different. So it's an adventure.
Yeah, and even from the AP development outside of Wi-Fi, there's new features that you guys are adding to the AP. Like I'm seeing APs become more functional, right?
Yes.
They're providing more features other than Wi-Fi, and I see new features on the 9136 that
Yeah.
I don't think I have even thought about using. Like what are some of those features and use cases there?
So environmental sensors is one, and they're in every AP item right now. And that, of course, was a response to some of the thinking that came around, um, you know, where we've been for the last couple of years about being able to monitor that. But IoT, of course, has been growing, and the requirements for automation, right? So it is
Mhm.
perfectly possible to put the environmental sensors onto the AP, and it turns out for not a lot of cost too. Um, you know, there's some engineering involved in that, right? How do you isolate that sensor from the hardware that's inside of it? What is an accurate temperature, right?
Mhm.
But yeah, the sensors was one thing, and I think we're going to see a lot more of that moving forward. You know, just finding out who's using your building has been a huge challenge that has been solved in a lot of ways. You know, some people use infrared, some people, you know, try to count clients, right, as they come into the office, but there's been nothing that's real perfect. The environmental sensors adds to that. I mean, how's your heating and air conditioning working? Is there a build? Are you getting adequate airflow? Um, so those are good. The other thing is we up the power on the USB module with the whole stack concept now. It's extremely easy to integrate an application on that AP. And the USB basically uses that uplink as an Ethernet port. So I've got memory, processor, and power to integrate through the USB port. Previous models had 4.5 watts. We've upped it to 9 watts on this model. And then, of course, we're introducing Clean Air Plus, which is that's the answer to Clean Air, which is how I got to Cisco. We brought Clean Air to Cisco.
Does that have to do with the RF ASIC that we've seen in previous APs?
Yeah, the RF ASIC is being deprecated. And the challenge there was, of course, we slapped 6 gigahertz on there with another 1200 megahertz to scan for. And a lot has changed. And I say this with all sincerity. I came into Cisco in 2007, and in 2007, it was very, very serious because everybody was in 2.4 gigahertz. And literally all somebody had to do was make popcorn and knock out 3 APs, right? it was
this microwave.
I spent a lot of years telling people 3 channels is not a lot of spectrum. Okay. But you know what? The microwave ovens, and I'll give you a quick story. When I was at, first at Cisco, of course, we were working on the Clean Air project, and that took us 3 years to bring to market. It was a lot of integration to be done. Just take, what was the Cognio Spectrum Expert answer and integrate that to an AP. One of the things we had all the time, I don't know if you remember or ever saw this, was I've got it right here. One of these little analog video cameras that you could power up with a 9-volt battery. I would challenge you and your listeners to go find me one of these on the internet today. Okay. They used to be made by Schwann, SCHWANN. And I called that manufacturer because I'd seen them as QC. I'd seen them as a lot of different brands, but I knew that Schwann was the one we found them at. I called there to find out why I couldn't find any. And they actually got the guy who was responsible for that project on the phone pretty quickly. And he came back and he said, yeah, he said, we had to discontinue that. He said, turns out it interferes with Wi-Fi. I cracked up and I sent an email to the other Cognio guys and I said, well, that's it. We win.
I mean, now there's a signature for analog cameras when we look at spectrum. So,
well, there is, and there still is, but the problems that we're solving now are a lot different than the problems that RF ASIC was meant to solve. I mean, it's cool to see. It's difficult now to buy a digital wireless or cordless phone that isn't in 1.9 gigahertz, right? And if it isn't there, it's in 5 gigahertz, and it's frequency hopping, but it's very not disruptive because it turns out Wi-Fi disrupts that as well. So I think the challenge that we have to solve now is a new 1200 megahertz, and that's where Clean Air Plus comes in, or the Clean Air Pro. Is going to come in and cover, because it's got scanning speed, brute force, still has got just about everything else has been written into Clean Air. I'm testing it now on the 9136. Clean Air Pro is the real deal.
Do you expect to see any interference on 6 gigahertz?
We don't know.
Okay.
Who knows?
I mean,
right?
Yeah.
It was real important for me to get a look at spectrum in 6 gigahertz because I've got experience on this. Until you prove that it's not your AP, it's your AP, right? In a customer's mind, if they have interference, if you say, well, it's got to be interference, that just never leaves anybody in a resolved state, right?
Yeah. I mean, I recently came off a project where they said we're having interference on 5 gigahertz, and I was like, really? We should validate that it is interference, and it wasn't the interference that I thought they were referring to, like RF interference. It was more like channel interference, but
self-interference rather than non-Wi-Fi or something that's not Wi-Fi. Yeah.
Right. So,
and that's far more common now, is us interfering with ourselves.
Yeah, it's all self-inflicted wounds is what we're running into. But
that's why we got 6 gigahertz.
More self-inflicted.
Well, we got a lot more room to run there. I'm hoping before we start arguing over that, I'm someplace in a retirement.
hopefully people will start following the actual design, recommendations. But speaking about the Clean Air Pro, like how different is that from the Clean Air that we are used to seeing today?
From a feature standpoint or a support standpoint, we've been working parity. It does support Spectrum to DNAC today. I just got the first build that does classifiers. Classifier support is going down. I mean, it's really hard to get these devices to interfere with. So we're still looking at the favorites, right? 802.11.15 protocols, Bluetooth, Zigbee, Thread, those sorts of things, microwave oven, video cameras, jammers. They all persisted, and I can tell you on a first pass, they're working pretty good. The other thing we got with this is the machine learning capability. This is being billed as a machine. Literally over the years, we have got thousands upon thousands of samples, right? So where that all goes to right now, in the initial programming, it's being supported by machine learning as we're doing the analysis. That is built into the radio. I don't know if we're going to be able to productize that in the future, but one day maybe you'll be able to find an interference source and say, that's icky and it's unique to me, and it would alert you on that. But it's still a little early for that. We're still just in the process of releasing that code, but that's 17.9 code. So I'm
okay. Yeah, I mean, no doubt we'll probably see some interference. I mean, it just kind of follows along in the spectrum, right? It was in 2.4.
I will believe we're going to be free. Yeah. I just think people say, well, what could possibly interfere there?
Yeah. And then we find something.
Murphy.
You jinxed it already just by saying that.
Yeah, I try not to.
All right. So given that there are all these new features, new radios on these APs, I think one of my more important questions around AP power, because I've had discussions with certain people that say, no, you won't need new switches. And then I sometimes say, like, depending on who the user is and how old their switches are, I'm like, yeah, you're going to need new switches. And I think a lot of people just don't think about that, right? They just think about the AP, I'll just swap it out, plug it in. And then you realize, like, hey, why aren't some of these APs powering up?
It's not just about power. It's also about throughput. And I can tell you, I got approached. It was almost 2 years ago. 2020, 2021. Some of these years get funny to try and remember in there. It was just like a long stretch that was 2 years and we all took it off, right? I got approached and they were like, look, I need you to tell me why I need a 5 gigabit per second Ethernet interface on an AP. And I do a lot of shows and things like that, like the rest of these wireless guys and probably yourself. I don't think you do. Right? You can't. It's really hard to hit that number over the air, particularly with a bunch of clients in there. It's counterintuitive. You'd think it'd be more, but you got more overhead that never comes off the AP when you have more clients, right?
Right.
So we went back, we did some testing. Turns out 80 megahertz is the gateway to 1 gig throughput, and you can do it all day long in 5 gigahertz if you can get away with an 80 megahertz channel. And that, I agree, that's not entirely practical, because I know for a fact, if you have more APs than we have channels, you're not doing 40 or you're not doing 80 for sure. You can get 40 if you're careful, in a reasonable size. So, that in itself it was eye-opening for me, because it wasn't that hard to get it. I mean, we clocked 2 gig on 5 gigahertz, right? But you throw a 6 gig on there, and in the US anyway, you're really pushed towards using 80 megahertz, and there's really no reason not to use an 80 megahertz cell. I've got 16 of them.
Yeah, there's plenty of spectrum there, so that might be the norm of channel selection, as
16 or 14. I can't remember off the top of it. Is a norm. That's what we're assuming on DBS is mandatory on 6 gigahertz on the controller code right now. So we're assuming 80 megahertz, and that's a good safe assumption. So you just opened up into 1 gig there. And if you take a look at all of the legacy that we left out of it, it's very easy to go over 2 gig on an AP now if you're talking about an enterprise drop-in. So power isn't the only consideration. And we did some extensive testing. What happens if I put one of these, you know, rockets on a 1 gig port? Pretty much what you'd expect. You know, video derates, it drops from 4K to 2K, right? It does, all the applications are used to not being able to go as fast or as slow, but it means you're going to spend more time sending the same information in a lot of cases. So, so there's a lot to consider there. And yes, adding more APs definitely hits power. Now that's controversial in a couple of ways, right? We usually count on silicon getting more efficient to get us over that hump. And we're just asking more of the technology faster and faster that we're not able to get that down. And then at a certain point, you're still broadcasting RF energy. So more radios requires more RF energy.
Mm-hmm.
So what is there anything new then with a power PoE coming out of the APs? Or I know I'm not just having people, you know, write off switches and just do replacement. I'm saying, you know, let's do some sort of audit, confirm like how many APs are going to join to a switch. Do we look at the data sheets for these APs and say, all right, here's the PoE max, and then plan for that type of PoE budget?
No, when we started releasing these, there were different power profiles, and you've seen those through the 9130. They've kind of picked up. They were hard coded, and they're still hard coded in our product up through 17.7. 17.8, we're introducing something called power profiles, and we got a lot of that delivered. Future versions of this are going to give me more controls to fine tune the power to what my organization needs, right? And everybody's running into the same problem. I've got 1 gig switches that I can't get over 30 watts on, and they aren't that old, right?
Mm-hmm.
Or we can't do anything about that until, you know, so it's a very real impact for folks. What this does is it lets you tailor the radios, tailor the order that the radios will shut down in, right? And this is just on or off for a given radio today. That USB port's 9 watts, right? So if it's there, the switch needs to have that 9 watts supported, or it's going to back up and go into, you know, some other power saving mode. So what's coming in 17.8 is control over that. Not only that, something that I've been looking to see for a long time, is a calendar program, which says I can invoke radios shutting down entirely between two points in time. So it's not just, you know, that we're sucking up more power. Using more energy is not very popular these days. Mm-hmm. Using less energy or being able to right size it is the direction that we're going, and that's to help people to try and you know, follow these trends and move to the future.
So do you have the details on the data sheet that says, you know, this radio is consuming X amount of watts and a USB port is using X amount of watts, so people can kind of plan their profile? Or how does that work?
No, that's going to be part of, I'm sure, part of the release options that come out with 17.8. So far, since everything's been hard coded, it's just really just the chart of what modes. Because this also happens when you negotiate the Ethernet connection. So whatever the switch can offer you max is what the AP is then going to make the decisions at that point in time on the initial connection. What's coming in 17.8 is the ability to not only give these power profiles that make a decision on how you want that AP to configure itself, given a different power budget, but it also gives you the ability to control those power profiles. For instance, if I wanted to shut everything down over the weekend without causing alarms across the system, I can shut down the radios, the USB ports, and conserve a lot. There's a huge savings in power. There's a half a watt of power in going from 5 gigahertz or 5 gigabits per second to 3 gigabits per second on the Ethernet port. So there's a lot of fine tuning. There's going to be a lot more data that comes out on how you can tune your power profile, and that's the theme that's carrying forward in a lot of the software that we've got in the works right now.
Okay, Yeah, so we're talking about a lot of different energy savings, energy consumption
Yeah.
savings going on
Yeah.
because the AP 9136 will have dual 5 gig in Ethernet interfaces, right?
It does have two 5 gigahertz Ethernet interfaces on it, two MGig
M gig, yeah.
gigabit per second. Yeah.
Yeah, so in that power profile, you could say on the weekend just shut down one of those ports. So we
I've
don't
got
need
control
both.
over which Ethernet port at literally every interface. And you'll see it in 17.8 code. It's under a power profile. And then
Yep.
there's also a calendar profile that you can pick the power profile up and apply that during days of the week or hours of the
Okay.
day.
Yeah, I wanted to go back to where you mentioned when the AP first joins, right? Because the
Yes.
profile would have to be downloaded to the AP from the controller through the config.
Yes.
Now, if you're provisioning that AP for the first time, it doesn't
Right.
have that profile. So there is then a sequence, like let's say the AP needs more than 30
That's
watts.
where the hard
but-
code. Yeah.
Okay, so then it'll shut
Yeah.
down certain things, like maybe the USB port won't be the first one to will be the first one to turn off so it has enough power.
The most minimal power mode, and people kind of kicked us a couple of times and said, why do you even have that? It doesn't support turning on any radios.
Mm-hmm.
Maybe I don't need radios. Maybe I'm the guy who's putting all these APs together and sending them out the door, and I just need them to connect to a switch so I can get in and push a config to it, right?
Yeah.
So that's the idea behind that. No matter how much power you got, I can make the LEDs glow and we can get a program into it.
Okay.
Once I push you a power profile, that's a profile change. So it's going to restart the AP and it's going to come up with the new power profile. And then whatever the power is on the switch that you plug into it, it's going to follow that order, right?
Gotcha.
Because, we did like every other manufacturer when we started to go above 30, watts. It was like, look, not everybody's going to have above 30 watts. What do you do? So we picked, some static things to shut down to give you some advantage. And then immediately afterwards, we got a lot of people said, well, what if my preference is this, or what if my preference is that? And good questions and inevitable. And now we're working on ways to give you a lot of control over it. So it's an interesting journey internally. Future things will derate radios or be able to give you the ability to really custom tailor the radio to the environment.
Okay. And how about AP support with that version of code 17.8? I mean, will that be supported on all APs that support 17.8, or is it just on starting from the 9136?
So right now in 17.8, these power profiles apply to all of the Catalyst series AP. So everything from the 9115 up or 9105 up is being supported in 17.8. And then 9136 and forward is being picked up in 17.9 profiles. So all the existing Catalyst line, this is immediately impactful to in 17.8 code.
Okay, great. So this means then for a lot of people, they don't necessarily have to upgrade all their switches. I mean, if you want to take full advantage of, dual M gig ports and every single feature on the AP, then yeah, you may need to upgrade your switching infrastructure. But at least for people who have, different budget cycles and maybe they're just phasing out APs to begin with and then switches later, you have options here. You're not going to be a sitting duck with new APs, but they're not powered by the switch port.
Right. Yeah. You should not have to, absolutely should not have to upgrade your switch to take advantage of new technologies or get into that. And that's kind of our position as well. I mean, I know we sell switches. We did not make more power consuming APs just so we could sell more switches, right? That's not how that was done.
But in the beginning, you did mention like you're going to want to watch throughput because now you have 6 gigahertz, 5 gigahertz, 2.4 gigahertz. If you meet all the PoE requirements, but you're still having 1 gig ports, you may want to keep your eye on that just in case.
Yeah, and as well as I do, there's customers out there that, me, if you make it go 1,000 miles an hour, I want a place I can point it and just see it do it, but but that's not what's required to support different business use cases. And there's a lot of low density, they just don't have a lot of capacity issues. It's more about coverage. So I mean, this gives us the ability to tailor that to the user's use case or business use case. It also gives us an opportunity to talk about switching and where it's going for the future. So I think every time we talk to a customer, and they might have a little shock at the power levels, which still comes up, it's something that you have to keep in mind, because you're only going to be as fast as your most efficient link. And for me, like I said, for me, it was really easy to discount the speed on the Ethernet, because, you know, let's face it, I've had several thousand people connected to a system all at once. And when you look at what they're actually doing on it, it's like, yeah, it's okay. Now you start to add in HoloLens and, you know, all of the amazing applications that, and there's a lot of them really coming down. A lot of people went home and found out how tough it was to run a video conference call while two teenagers were looking at Netflix, right? So, so I think the use cases are definitely coming for most businesses. And this is taking a look at the whole system to get your needs out of what you need for the business. It's a good time to do that.
And so on the 9136, if you have two Ethernet cables, two Ethernet interfaces, could you have them connected to two different switches if you want like redundancy? Okay.
Yes.
And could you have power coming in on both interfaces? No. Okay.
No.
All right.
We don't do additive power, but we give you the option to either set those two Ethernet interfaces up in a lag mode to get combined power. For instance, your use case might be you only have 1 gig switch, but you want to span two switches and pick up, or two ports and pick up, you know, 2 gig capability from it. Or we support a fully redundant capability, which means you've got a like switch port on the other side in case there's a power hit or anything else that hits the one switch. So full redundancy.
That's interesting. And then also I had another question regarding the power profiles. Could you have a power profiles that completely turn the AP off? Like, let's say, you know, if you schedule it for the weekend to be off or something like this?
Not yet.
Okay, because that would have to come at the switch level, right? If you want to turn it back on.
Right. And then there's a whole lot of upstream that goes with that, right? Because then if you shut the AP off completely, what's its time to recovery if somebody does come in, right? So there's a lot of conversations about that right now, how I dimension a system, how I detect a user, or how I detect where they're going. So there's been an awful lot of interesting conversations on how we can squeeze power out of, you know, unused power out of a budget. And this is all recent conversations for wireless, right? I mean, how long have we been building, you know, for the worst case and hoping for the best case, right?
Yeah, I know. I do some event support, and we do a lot of turning APs on and off depending on, you know, if you have people in the building or not.
Right. But then you've got alarms going off on the management panels too, right? Because it can't.
Yeah, we don't care about these.
Yeah, now you squelch them and it's all good. But the point is, it's not an error. It shouldn't be alarming, right? I mean, we should have a coordinated, graceful way of saying, hey, they've all gone home. I want you to leave these 5 APs on, and I want you to up their power so that they have a wider coverage, right? Because I don't have
that would be nice.
You obviously don't get calls from the network operations team, Francois. I would get those calls if those APs went down.
They'll call you.
But I guess you could somehow implement something similar where, if you do bring the AP down, maybe you have to use APIs, but create notify the system, like don't alert because systematically these got brought down for, you know, whatever reason. But I mean, that's a different discussion, but I see where you're going with it. But my concerns would be, now there's people, we got to bring them back up from the down state, but they were scheduled to come up at a different time.
Well, that's when interconnecting the, you know, let's say the security system or the card reader. All this stuff could help you, because you could just detect someone coming in the building and then turning the AP on and and you know, make sure the Wi-Fi is ready. It's not the coffee ready. Make sure the Wi-Fi is ready when the person arrives at the desk.
Once the Wi-Fi turns on, also trigger the coffee machine to turn on. Like I can see.
See, no, that's good, because the first thing I want to do while I'm standing waiting for that coffee is to check email while I'm literally waiting for that coffee, right?
Let's talk about because with the new 6 gigahertz coming, we have all these other rules. There's AFC. I
Mhm.
guess real brief, like what does that look like for us? Is it, I know there, it seemed like a phase 2 type of approach.
Oh, it is very much.
Okay.
Yeah. So one of the concerns with 6 gigahertz, there's never been in my entire adult life, there's never been a frequency range in the spectrum that we can get to technologically that's been open. I mean, somebody's everywhere, right? And technologies improve and advance. That's how we got all of our grants in 5 gigahertz. 6 gigahertz is no different. There's incumbents in 6 gigahertz that are actively using frequencies that are in the range that we're using. Most notably, ground stations for satellite links. And then we've got, you've heard electronic news gathering is probably one of the most prevalent out there. And that gets into a lot, right? So when you see those trucks, and we just had a couple of the carriers check in and they've been using backhaul microwave links in the same frequency ranges. So this is normal. It's affecting a lot larger segment across the country. And some of those broadcasters and incumbents have got legal rights in that band, and they're concerned about, and they're not convinced with the argument that low power indoors is going to, prevent interference with their operations. What they're even less concerned of is if we get outside without any restrictions, because Wi-Fi in the rest of the radio world, it's by definition accessible technology, right? So a lot of people don't understand when you say in Wi-Fi, hey, keep your antenna below 30 degrees, from the horizon, right? Don't bounce it off the moon and interfere with the guy in Texas, please. All right. So AFC is designed to give those broadcasters and incumbents of all sorts protection by creating that database that says, look, we can run outside and we get up to 36 dB of power. We get any antenna we want to put on it as long as it's within the legal limit of EIRP. So it gives us a tremendous amount of flexibility, but it also increases our responsibility. We basically have to tell a data system or an automatic frequency coordination system where we're installed and where the antennas are pointing and how much power and what channels we're using.
Yeah, and that's when we start to talk about outdoor and that.
Go ahead.
Yeah, so we were talking about the fact that in 6 gigahertz they have different regulations for indoor versus outdoor. So indoor they call it the low power indoor.
Yes.
And then AFC would be required for operation outdoors, like you said, to make sure that we're not creating interferences. The tricky part with AFC, like you said, is having some sort of common database that we can check against to make sure that we will be the only radio in the area operating and so on.
Yeah, so that actually exists, right? I mean, that database, the FCC keeps that data, and some other regulatories do have that capability. The FCC's is pretty advanced. The data is good in it, and we know that. So that gives us immediately, and that data has already been tapped already for CBRS, and other things. So this is by no means a new concept. Cognitive radio or being able to automatically coordinate these frequency assignments. What was new for 6 gigahertz, because it's a different spectrum, a different transmission type, was what makes sense as far as how much protections to put around incumbents' plans, right? So that's where the AFC actually comes in, and it comes in by giving us the mechanism to first interact with once a day. My AP will receive communications from an AFC telling me what channel range and what powers I'm allowed to operate in. And keep in mind, outdoor operations skips over Uni 6 and Uni 8 to protect those users, right? So we're only going to get 5 and 7 outdoors.
That's for the US.
What's that?
That's for the US, because in Canada they do have it. Yeah.
Well, yeah, okay. So that's for the US only. Where's the other AFC?
No, I don't know.
It
That's the
isn't
thing.
one yet, right? Yeah. So well, I'm not intentionally leaving out any data. I promise you. So we're still waiting
Yeah.
to see how that works. But it requires that you tell them where it's at, what type of antenna it's using, where it's installed in the system, and then we're using the same terrain mapping software that's already been in existence and is being used to keep all these other frequencies from interfering with each other. So we're just AFC from a mechanism standpoint involving APs, and it's a different level because we're going to make that transparent to the user, right? So if you get a standard power AP, AFC is built in, baked into the controller, and that conversation happens without the user having to do much, if anything at all, other than that GPS coordinate that comes from the AP. So the database knows where you're at.
So you need internet access.
You absolutely have to have internet access. Yeah, there's no.
What
way
if you're
to
doing an
do
AP on a
without
stick?
that. Well, if you're doing an AP on a stick, then you're going to need a controller right now. But that's unfair because we haven't released a standard power AP yet.
Yeah, you're right. We're talking about future problems.
Yeah, we really are, because I last week I just got over looking at mock-ups of what that interface might look at for somebody troubleshooting it on the back end. So yeah, it's future problems, but we'll see. I mean, all of this, look, we're on a journey with an amazing one that's going to be fun, but this is newer than anybody who's in Wi-Fi today has seen in some time. DFS is about the only analog you can draw, and even that's not the same because we didn't change all the interaction between the clients and the APs. We just changed the AP's behavior, right, and made it locally significant. So there's some good things coming.
Yeah, I wonder how this database also would be shared, in between countries. So let's say you are at the border with, I don't know, the US and Mexico. Will that cause an issue? You know what I mean? Or will the two countries share their database?
I don't know if you know this, but there's actually 2 zones in the US that borders Canada.
There's a wall? That's what you're going to say?
There's a wall? No, where we actually have a different regulatory for those zones, right? Because of their proximity with another regulatory. So yeah, this is not new. All these things are dealt with today, not in Wi-Fi, right? But we're now bringing Wi-Fi into that, right? And there's a tremendous amount of spectrum that goes unused on a daily basis, right? So if I'm not using it, I don't care if somebody else uses it, right? It's just a matter of keeping it available for someone who has the first right of use. And that's Wi-Fi. Wi-Fi has been opportunistic since day one, and we are the politest people with radios in the world in that we accept all interference and we just get out of your way, man. It's like, you want to use it? That's fine. I'll go over here, right?
Yeah.
It only becomes a problem or a challenge for us when it becomes as wildly popular as it is now. We fill up all of 5 gigahertz.
Even more popular.
The biggest enemy to Wi-Fi is Wi-Fi now. Yeah.
We are feeling our own success. Yes, we are.
And so do you think it'll be a few years then until we can actually use antennas outdoors?
No,
these 6 gigahertz outdoors?
No, it's not going to be that long. No, I'm not going to commit to a timeline right now, but it's going to be within the next year. We'll be testing this stuff.
Yeah, but essentially, there's AFC is making progress, and then we'll soon get APs with external connectors on 6 gigahertz.
Yes,
and we'll be there soon.
I had a 1-hour AFC team meeting just before this call, so it's steady progress, and industry wide from a standards perspective, there's a tremendous number. You guys all know that at a certain level, we're all talking together because there's a certain amount of the tide that floats all boats. This is one of them.
Yeah, and I know they had some discussion about external antennas connected to a low power indoor IP, because according to the standard, you can have external connectors, but then I don't know, there's some ways to go around the writing.
Well, the intent of that writing was non-removable, that the customer can't alter the AP, because we've always had that rule. You know, you can only use these antennas on the AP, right? But if you, the customer, want to go out and buy Bob's antenna, you know, off the internet and somehow manage to put that on your AP, that's fine. As a manufacturer, I certify with that project, and what you did is illegal, and you don't charge me with that, right? That's entirely what happens there. Because there's incumbents with real financial interest here, that's no longer acceptable, right? So we need to protect, we need to be good neighbors, right? So that's where the intent of that was, but it should not be customer alterable, meaning if I mount that antenna with a given aperture or AP with a given aperture antenna, unless I'm the manufacturer through some manufacturing process, I can't change how that radio is going to operate.
So do you see like a version of this 9136 with a connector onto, we can connect like external antenna for like warehouses or indoor environments, but with like non-removable external antennas? Is that something that you can see happening in the future, or will you guys wait for just having, you know, the standard power AP ready to go for external antennas? Do you understand what I'm saying?
I do, but I really,
you can't talk about
it. That'll wind us with us back here taking a whole nother shot at this.
I know it's okay. So I know, Roald, you wanted to move on, but one thing that I was really interested in that we didn't talk about for the 9136 was the antennas. I have this antenna with me, which is, maybe Jim, you'll recognize that.
I do. That is the dual band spittoon.
Yeah. So that's the antenna you have in some of your APs, right? 2802 and 9120.
Well, they're soldered to the board and that little wire goes someplace, but yes.
yes. Someone gave it to me, and now I when I train, I just show it because it's nice to see the element. Yeah.
You know what? I think it is good. And I actually have an exploded view with all of the antennas are on the 9136. I mentioned that I did not have that at launch time, but that is the value of Mr. Fred Niehaus returning to us.
And so now that we have 6 gigahertz, I'm guessing the antenna is different, right? Or you guys added a new antenna, or did you design a new antenna with more elements?
Let me. You want to look
for
at
the visuals?
Yeah, picture. Yeah, let's do that. I think a picture is going to be really helpful here.
Good opportunity for us to mention that, you know, this is available on YouTube. If you guys are listening, the podcast version, you can check out the YouTube channels and get the visual. We'll try to describe it for you guys as much as possible.
So the 9136 does add 4 spatial streams at 6 gigahertz, right? And this is very, very similar to the layout and the design that the Catalyst 9130 had, right? Which the 9130 had dual 2.4 and 5 gigahertz antennas for the 4 spatial streams on 2.4. The slot 1 radio, which is 1/2 of that 8x8 in 5 gigahertz. Then the second half of that 8x8 was served by band-locked 5 gigahertz dedicated antennas, 4 of those at the center of the radio. We also had dedicated antennas for the scanning radio, the RF ASIC, and we had dedicated antennas for the IoT radio. So you didn't lose any spatial streams at any point by operating any of it. The 9136 adds 4 6 gigahertz radio chains. So those 4 radios, that 5, 6, 7, and 8 radio that's at the center of the C9130 now also supports 6 gigahertz, and those became dual band 5 and 6 gigahertz because I can radiate an antenna in 2 completely separate frequency ranges, right? But I can't do 2 5 gigahertz on the same antenna.
Okay.
So that really was a nice change that was fairly easy to make, because I can tell you our antenna folks are, you know, like you and me, and if you see 6 gigahertz coming, you're boning up on that and how you make dual band antennas and, you know, all those kinds of crazy answers that you expect people are going to start asking questions for pretty soon. So even back in the Marlin antennas, were all dual band 5 and 6 gigahertz, except for the Marlin 4. So everything that we built in 6X antennas or Wi-Fi 6 antennas has been dual band 5 and 6 gigahertz for some time.
Interesting. Okay.
Yeah, that's interesting.
Yeah, I remember when we first put the 4800 out, and I got my clear lucite topped one, and you could just count the 26 antennas under that ray dome, and it was,
yeah,
man, that's a lot of antennas right close to each other. Them guys know what they're doing.
It's almost like
my
an
antenna
art.
guys, they deal with software that makes my head hurt. So
Yeah, I can't have a discussion with them. I wouldn't know. Like the whole hardware design and antenna design, it goes over my head completely.
it's a lot of math. But you know what? It's physics. And like they point out to me frequently, physics relies on constants, which is refreshing because nothing else is.
Yeah, exactly. Like, it's nice that they're able to still be creative and come up with new solutions, right? You would think like with these antennas, like that's it. That's whatever we came up with, that's all we can do. Can't do any better.
we are miles beyond where I thought we'd go. If I look back to the beginning of my career when we were just trying to figure out how to get video over Ethernet, right? Yeah, it's amazing what we can do. And you're right, it keeps being creative people who are like, well, I don't see why you couldn't do this. And like, by golly, look at that works. So, yeah, and then there's a lot of hard work going on right now in standards. That's what's exciting about the market today. You mentioned 6 gigahertz bringing on new challenges, but man, we fixed what was accumulated baggage with Wi-Fi by jumping into Wi-Fi 6 and jumping into 6E. So this is a do-over.
There's room for innovation. Yeah,
plenty of room for innovation. I think we're going to keep this to be. If you look at this as your favorite sport, we've got plenty of opportunity to play coming. So,
well, why don't you talk then how that impacts RRM? A lot of us are familiar with RRM and how it works, but does this change with Wi-Fi 6 and 6E? Does this change how RRM operates?
Fundamentally, no. But it does increase the challenges quite a bit. And then, yeah, even fundamentally, it does with the way the FCC and put the rules with power spectral density in place, right? So now I got to keep track of what my maximum power is, at 20, 40, 80, 160, right? So that's just another dimension that RRM's been dealing with. RRM's one of those algorithms that has grown. If you think about what we've added to it, 802.11n, 802.11ac, and now, Wi-Fi 6 and 6E and all the spectrum, the algorithm has grown tremendously. The primary challenges are getting users to use them, right? And everybody's going to have their own secret sauce. But clients pick the AP they want to join. That's pretty much how that works. Now, WFA has been doing a lot of work, as well as so have the client manufacturers. And we even work closer with the client manufacturers now. We've got what we call the device ecosystem, which we're all working together to ensure these transitions are smooth. From an RRM standpoint, it's a lot more channels, right? And it's another dimension, right? Because I've got 6 gigahertz, which is going to be probably in every aspect much higher performance than 5 gigahertz, just because of the efficiencies and channel bandwidth and no incumbents. So yes, RRM's changed a lot. FRA's changed a lot. In one aspect, it's huge changes. In another aspect, it's continuously changing. Right. I mean, we've had new frequencies or new protocols being released all the time, and how those operate in the presence of legacy protocols requires constant looking at what's efficient, what makes sense, what doesn't make sense. So from the RRM guys' standpoint, they were like, oh, great. Yeah, well, I guess we still got a product this year, right? But it's getting much more it's getting more intelligent. And the clients are getting a lot more intelligent because, you know, when we first went into 5 gigahertz, God, getting a client to use 5 gigahertz seemed like it took forever to tell everybody, look, just because it's louder doesn't mean it's better. Right. So yeah, AI RRM, as I presume that's where you were leading.
Yeah, like I want to know
What's the
how is it
AI?
using AI. I mean, I hear a lot of companies throw around AI, but
Yeah. Yeah.
how
It's
does
what you
that
want to
get
tack
used?
onto anything, right?
It's the trend, right? Everyone wants
Yeah.
AI
Yeah.
and ML to be thrown in there, but I guess with RRM, is it gonna
Don't forget
utilize
MR. Machine
a
reasoning
machine?
has to be there if you're going to learn anything and then figure out how to apply it, you
Yeah.
know, right. So AI enhanced RRM. Well, right off the bat, and it's just another one of those things. RRM continues to amaze me at how those algorithms were designed, because literally every time we have a challenge, there's a place to hang it, right? And it's like 10 years ago, this was there because we did this. Now look at that. We can leverage that and roll right in, which is where AI enhanced RRM comes in. The amount of data that's collected from each one of the APs has continued to, you know, with data science, get smaller, but it's still tremendous amount of, and not immediate importance data, but it is trend data that we're collecting, because we have a changing spectrum and changing loads throughout the course of the day. And that's the first thing that AI enhanced RRM does, is it gives me that data repository. So we brought big data to RRM. We already collected a ton of data at any point in time on our controller. You can literally put your finger on how every AP hears every other AP, right? So that has always been limited to DCA cycle time of 10 minutes, right? And if you anchor that time because you don't have good tolerance for channel changes or applications that are dependent, it's mission critical. If you anchor that time, it means that we make that calculation then. But there's no facility within the controller itself to be able to manage and look at that data set. When you go to AI enhanced RRM, we're building a 2-week data set, and we're looking for those trends, and we're looking, we've got business hour sensitivities, right? So we can look at the conditions at noon for a class change in a university, and we can optimize the configurations that we apply to it after hours, if that's the user's choice, for those peak times, right? So the other thing that we did was RRM. If you looked at my slide deck from Cisco Live, I've got this, you know, it's a gag, but it's a game controller with 1,000 buttons, rotators, and dials on it. And that I hate to say, but that's kind of what RRM's become. I can make RRM do anything, but that's because I'm at the bottom of every feature we're discussing going in, and I know it's there, and I know why it's there. To solve that problem, I think the user needs to be a lot less engaged, and certainly, well, you guys can speak to this. Wireless professionals, when you get to an organization, there may be, you know, 100 people in an IT organization and 2 wireless guys, right? and they're responsible for the entirety of the stack all the way back to where it roosts on the back end. So making that easier, and it's become a much bigger problem now. We've got controllers that can manage 6,000 APs. It was no big deal when 50 APs was a huge network, right? So a lot of that comes together. We finally got to build the control panel, or the control center within, you know, Cisco's DNA center assurance, that I've always envisioned. And we've kept this simple. I don't know if you're familiar with, you know, the health metric that we develop out of some of the tools like the config analyzer that, you know, TAC uses and escalations uses. We produce a really intuitive health metric out of that. That's been carried across. So all of the good ideas and how we manage it today, we put into a machine. That's where the AI comes in. So now I'm actually getting good insights from the algorithm, and the insights are, hey, we think you could really benefit from DBS, or we think you could really benefit from FRA, or we noticed you configured your busy hours this. We're really seeing this. Do you maybe want to change that? And then going even further than that, you click on that insight, it will take you to why we think we made that decision. And it'll take you right through, walk you through with a walk me through the configuration changes. And do you want to implement it now or later, or not at all? So you're free as an admin to say, not at all, quit bugging me. We've all had an AP that needs to get changed out, and it's not going to be till next year, but it's number one in your alarm list every day. Right?
Oh yeah,
And
I've
you
seen
just
that.
aren't going to be able to fix it for whatever reasons until then. You can ignore these and put them on hold. So yeah, it's a really usable dashboard. I was using it at Mobile World Congress in February. We ran the booth and the press area on it. So that's a vote on confidence. It takes, Mobile World Congress is a very large international show, and there's a lot of communications press in that room. We ran that room on AI Enhanced Rrm.
So will it even make recommendations for when people misconfigure some things? Like maybe you are operating on 80 megahertz on 5 gigahertz, but you shouldn't, and it says maybe you should drop it down. Like does it help in that aspect as well?
It is my fervent belief that it will. We're just getting started now on the back end, looking at the amount of data is unbelievable. And the context that I can see that data in is unbelievable. Data science is cool stuff. Beats the heck out of that big text file that I parsed manually, right? So
and do the brains of that operation live on the controller, or is it something within DNA Center? Like how, where do those decisions are made?
That's the beautiful thing. Okay, so DNA Center today, when you provision a controller, it becomes the control layer for the controller for any changes, but it's also the data layer for transmitting any of the telemetry back. The algorithms reside in the Cisco Analytics Cloud, and DNA Center provides the conduit for getting on and off of the controller. From a architectural standpoint, RRM has always had an RF group leader. And this is that hook that I told you about, just keeps kind of paying dividends. The cloud just becomes my RF group leader. And DNA Center pushes the RF profiles that I'm going to enforce. It's an AI RF profile from DNA Center. But if that cloud goes away for any reason, I've got a timer. I should have heard from DNA Center. And if I didn't hear from DNA Center or the cloud for RRM, I assume I'm my own RF group leader and I have the same RF profiles that I had 5 minutes before. I just start running the algorithms. So it's the data's off platform and the compute power's off platform, but it's very much the same algorithms that were on platform, plus a lot of analysis and looking at that. So config changes, whether you picked high density, low density, medium density, all of those things are very possible. We're just starting to do the work now to go into those insights and make them much more happy.
Yeah, because then now I can see that you can add more data sets there.
You
and
can
be able to push that down to the controllers rather than
Yep.
Having maybe one version have a set of data sets and you have to upgrade to another code version in order to support that data set. At least you wouldn't have to do that.
Plenty of places where we configure resources now based on the Black Friday, or user mob, flash mob kind of thinking, always design for the worst and hope for the best, right? So I think this gives us a lot of insight into that. We can actually find those trends and adopt. And it's my hope one day we'll be able to swing resources around where we need them based on the history of an organization.
Yeah.
So
could you see this being implemented for Meraki as well?
I could.
Yeah, because that would be helpful for us. I see a lot of I do a lot of troubleshooting sometimes, and
it's getting a whole lot more likely that it might.
Yeah.
So yeah,
I mean, if it's already in the cloud, yeah.
It's a matter of getting the data up to the cloud and the assignments back down. They're still just channel and power, right? And some feature control like DBS and FRA instruction. But what goes to the controller ultimately just tells an AP what to do.
Yeah, that's cool. That's a big change from traditional RRM, seeing all these improvements, and now being able to push better configs, better troubleshooting, being more proactive rather than, and also the insight, right? Because I think a lot of people just didn't know how RRM made its decisions. Now they'll be able to see, like, here's the reason why you should make this change.
And there's a lot of default RRM too, right? Maybe that can help.
Well, yeah. And the problem there is, and I tell people this all the time, you guys probably get that, but density. The closer APs are together, the fewer configuration choices I can make, right? Or the more restrictive my choices are, because we always have to maintain isolation. So how close or how far apart your APs are makes all the difference in how you're going to configure those APs. If I know how close or how far apart and what your use case is, I can build a config that makes it sing. But when people say, oh no, I'm high density, I'm medium density, I'm low density, you know, we all, that is a subjective measurement, right? So we've even got a concept in Enhanced Rrm about the network density metric, and that's giving you just a count of the number of APs that can be heard above whatever threshold we happen to be setting on that. So with that data and really what was put into this, I look at it now, everything that I need to troubleshoot is already encased in there. And now we're getting down to how I look at it and how I evaluate things, along with a lot of other smart people. So yeah, don't want to give the impression I'm doing this without adult supervision. I'm supervised. But yeah, it's exciting. I think there's going to come a time where I'm going to work myself out of a job because we don't need me on RRM. That'd be a nice legacy to leave behind. One day, say, I used to do all these complicated things. Now you put a quarter in, push a button.
It would be a Bitcoin. You put a Bitcoin in.
So you'd want to get started on that rather quick, wouldn't you?
Don't give them ideas for so.
No.
All right. Well, Jim, I'm glad you're able to join us on this discussion, talking about the 9136, all its capabilities with Wi-Fi 6 and 6E, going into AP power and throughput that it's going to be capable of. Also giving us some insight around what's happening with AFC, because I know that's kind of hard to follow sometimes, like knowing where to go to get that kind of information can be difficult. And then giving us a glimpse into the new version of RRM and what that's going to be able to provide for us. It's a lot of good information. I think it's a lot to unpack, and I know I'll probably rewatch this episode again just to get myself familiar again with all these different data concepts and all that. So looking forward to trying it out for myself.
Excellent. Well, Raul, Francois, thank you so much for asking me to come out and talk about this. There's just so much going on right now that I'm really happy people want to talk about it, because we're busy. We're busy inside, and I know it's hard to get information because everybody's been kind of waiting, and it's like, yeah, we're building it. Yeah, this isn't just another model car with a new hood ornament. This is, we're starting from the concept of wheels up, right? Yeah. But it's a really exciting time, and I really appreciate you giving me the time to chat about it today.
Yeah, of course.
Thank you.
So if anyone has any questions, feel free to leave them down in the comments below, and we'll be reading those and responding to anyone. And I'm sure you guys will have some questions. So look out for future episodes as well from Cisco. We'll also probably be playing with the 9136 and trying to share our thoughts and tips from doing that.
Encourage you to get into some AI RRM too. The AI Enhanced Rrm is a release product. And if you've got DNA Center and a license, Advantage license, then you've got everything you need to get started with that.
All right, there you go. So thank you guys for listening or watching if you're watching the YouTube video, and we'll see you guys on the next episode. Bye, guys.
Thank you, guys. Bye-bye.
Thanks.